Okay, good morning, Year 11. Right, so we're starting a different topic today. We thank you very much for all the feedback from the proportionality from last week. Really good, really positive. So well done. Keep going. We're going to be looking at trigonometric curves and solving trig equations today. Now, this is one of the sort of grade 8, grade 9 topics, but I still think everyone should better pick some marks up on it. So bear with me. What we'll do tomorrow in Tuesday's lesson, we will pick up any issues. We're going to do a live session. So make sure you're free at 12:30 tomorrow, and then we will talk through it a bit more. But I think we'll certainly all better get started today. So just to get us thinking, get our brains going, 4 questions on the screen there, all about finding missing sides, angles, etc. So have a go at those. As always, the answers are on the next slide. Okay, so if you haven't paused the video, I'm about to go on to the next slide. So here are the answers. So the first one, we needed to use tan. Opposite over adjacent, we know the adjacent is 4.1, so we need to do 4.1 times tan of 24 to get our value of our opposite. This one here, we're trying to find the angle, but we've got the adjacent and the hypotenuse, so we need to use cosine. So it's 3.5 divided by 10.4, but then you need to do the inverse of cosine, so it works back to the angle. So you end up with 70.3 degrees. You have to do the shift or second function on your calculator with the value you've just got from your division. This one, be really careful. Don't think, oh, I need to use trigonometry for all of them. This one's actually a Pythagoras. And we're finding one of the shorter sides, so it's 7.1 squared, take away 3.4 squared, and then don't forget to square root at the end, so we end up with 6.2. And the last one here, slightly more involved, couple of steps. We need to find the area of the triangle, so probably the best way to do it is work out the perpendicular height. So we've got our angle, we've got our opposite, we need to work out our adjacent, so let's rearrange it. 6 divided by tan of 60 gives us the height, and then it's just basically 6 times 3.464. That should say divided by 2 on there, but sorry, I've just cut it off the bottom, which obviously gives us an area of 10.4 centimetres squared there. So just make sure you're using the right units. So that is sort of a bit overview of right angle triangles, trigonometry and Pythagoras. Now, what we're going to look at today is where these values come from. So what does that actually mean? When you do 3.5 divided by 10.4, you get a load of decimals, you press this function on your calculator and you get 70.3. Well, there is a mathematical reason where that comes from and what your calculator's doing, which we're going to explore a bit today. So the first thing we are going to do is we're going to look at the sine curve. Now you may have already seen these. I think in one of your mock exams it had the it was either sine or cosine curve towards the back of the paper. But I'm going to kind of hopefully show you how it's generated and where it's come from. So I would normally get you to draw these out on graph paper, but I think probably not many of you have got graph paper at home. So if you just watch what's going on, and then I'll give you an opportunity to sketch the graphs at the end. Okay, so we are going to be looking at, as I say, the sine curve to start with. We've got a circle drawn. It has a radius of 1, which is quite important, and we're going to draw a triangle in it. It's a 45 degrees. Okay, the hypotenuse is 1, and what we've actually got, we can work out this height here. Now, because the hypotenuse is 1, we're going to obviously use SOHCAHTOA. I've already established we're using sine. Sine is the opposite over the hypotenuse. Okay, so that's what we've got. Sine of 45 is opposite the unknown length divided by 1. So actually this unknown length here is actually sine of 45, because something divided by 1 is still something. So instead of 45 degrees, the angle is A, and the y coordinate of this circle should be sine A. So in other words, I'll explain what that means. If this angle here got bigger, so say it was, I don't know, 60 degrees, this length here would be sine 60. If this angle here was, I don't know, 15 degrees, this height here, obviously your triangle would change, and it would be sine 15. So it does depend on the size of the angle. Now hopefully you've got your calculator to hand. If you haven't, you do need it for this. So we've just said if you do the inverse sine 45 on your calculator, you will get this value here. So let's just, I can't remember what sine 45 is. Sine of 45 is, oh come on, oh, I'm in radians, hold on, sorry. Right, sorry, I thought that didn't look right. When you get onto A level, you also measure angles in radians, but you don't need to worry about that at the moment. So if you do sine 45 on your calculator, you get root 2 over 2, which is 0.707. So I've marked that point there. Now, as we work round, carrying on with our, as I said, you can have different size triangles. So if we did sine of 30, so you can do sine of 30 on your calculator, you get a lower value, you actually get half. Smaller angle, you can pick, I don't know, pick 10, 15, whatever you want, and you can see it's smaller. Now, as the angle gets bigger, this gets bigger, so we keep going. So you could do sine 80, sine 85 until you do sine 90, and when you do sine 90, you actually end up with 1. Now that is the top. That's the longest length this height can get. And then as you go over to the other side, this angle here now is 135. So you can do sine 135, and you can see your graph is gradually working its way back down until you do sine of 180. So sine of 180 should give you 0. So we're back down here and we're beginning to get our curve forming. Now, what happens now when we go further? So if you do sine, I don't know, so sine of 220, I can't remember what the next one on the slide is, you will find you're getting negative ones. So you're gradually working your way down. And the reason why it's negative is because the y value below the x-axis, these are negative. They're down below the line. So that's -1. So that there is going to be minus 0. Whatever it was, 707. So it just works into the negative. And then it will gradually work its way around, following the circle, until you get right back to 360 and 0. And that's a complete circle of the graph. And that is your sine curve. Okay, goes from 0 to 360, but then it repeats. It keeps on going around. So you can carry it on, and a lot of the questions you end up doing, it will give you a limit or a sort of an inequality saying you're working between 0 and 360 or minus 180 and 80. But we've got 0 to 360 drawn here. And the equation that we are going to solve, because this is kind of where we would be using it, is sine x equals 0.5. So you're probably thinking, well, that's fairly straightforward. You just do inverse sine 0.5. and you end up with 30 degrees. Well, you would be spot on with that. Okay, so remember you're finding the angle now, so you do the inverse, but that's your 30 degrees. But you also notice we've got a point here. Okay, so that's 30 degrees. We did inverse sine of 0.5 and that's 30. But actually we've got this value here. So there are two answers to this equation between 0 and 360. You would have the something like this written out. So to tell you you're working between those values. So this value here, we've got our one at 30. We also can work out this one, because this is symmetrical about this point here. Okay, so if that's gone in 30, that's gone in 30, and you'll see that our other answer is actually going to be 150, because it's 180 take away the 30. They're symmetrical. So we've actually solved our first trigonometric equation. Okay, so tap 1 in the calculator to get our principal value, it's called, and then we've actually worked out the other one because that is 30 degrees down from 180. Okay, so that's how you would use the sine curve to actually solve these equations. Okay, so let's go on to the next one. As I say, it does go on and on, but actually we're just working in between 0 and 360 at the moment. Now, the next curve we're going to do is the cosine curve. So we stick with our 45 degree angle in our triangle. We've got our unit circle again, so our hypotenuse is 1, but this time we're actually looking at this length, the horizontal length, and you will hopefully see that as the angle gets smaller, your horizontal length will get bigger. Likewise, as the angle gets bigger, closer to 90, this length gets shorter. And you can try, we know we're using cosine, works in exactly the same way because we've got the unit circle, we've got a hypotenuse of 1, so cosine of 45 is equal to the question mark, or actually the horizontal distance. Don't know why I've put a question mark in there. Right, so let's see what it actually looks like when we draw it out. Again, you can do cosine of 45 on your calculator, which gives you root 2 over 2, 7.07, which is exactly the same value, I know, and you'll see why in a minute. But actually, as you make the angle smaller, the this length here, or the value on the y-axis, gets longer, or gets bigger. So it goes all the way up to 1. Okay, so when you do cosine of 0, you should get 1. Okay, and likewise, if you do the cosine of 90, you will get 0. Now, just like the sine curve, when we went below the x-axis, it went negative. Now, because we're measuring this the length, the horizontal, as soon as we go to the left-hand side of the y-axis, these are all negative values. So you can carry on working your way around, 135, whatever values you want to put in, you will find that your curve starts to take shape, and we end up with our cosine curve. Very, very similar to the sine curve. In fact, it's the same curve, it's just been translated along 90 degrees. So this is 0 and 1, whereas the sine curve was 90 and 1. So it's just shifted along 90 degrees really. So what I'm going to ask you to do, okay, see if you can solve that, bearing in mind what we did on the previous one. So I'm going to give you, well, obviously just pause the video, have a go, see if you can figure it out, and then we'll have a look. Okay, so hopefully you did on your calculator the inverse function of 0.45, which would have given you oh, that's not a very nice number, is it? 63.25. But hopefully you realise that actually, well, I've got 63.26 when I round it. Okay, it is 63.26. But it's this value here that you've just worked out. Sorry, this value here. So that is going to be your 63. Let's call it 63.3. So we're not arguing over the second decimal point, but you can also see there is another value here. Okay, so we need to find a way of working out that value. Okay, now hopefully some of you realise again we've got our line of symmetry. So because that length there is 63.3, that length there is 63.3. So what we can do is we can do 360, take away our 63.3 or 27, and we get our second value. Okay, so we still have two values. Even if we did a negative one, if we did, for example, let's try one. Yes, let's try one. So let's do cosine of x is minus 0.45. Okay, tap it in your calculator, see what you get. So pause the video and then we'll have a look at it. Okay, so if we therefore do, oops, so that should be a minus, I've lost my minus 0.45, tap it into the calculator, you get an answer of 116.7. Okay, well, again, that's your principal value. So what do we do? 0.45, so it's going to be about there. So that value there is 116.7. Well, symmetrical, so actually you can do 360, take away that value, so your other value is going to be 360 minus 116.7, and that will give you the other value, okay, which is 243. Again, we're only working between 0 and 360. Okay, it does just carry on as you keep going around the circle, your graph keeps on being generated. Okay, and what we're actually doing is we're solving these trig equations. Okay, that was quite a brief-ish explanation. Now, what I propose to do is tomorrow, so in Tuesday's lesson, we are actually going to have a live session. So I have got some questions for you to have a go at, but I very much imagine that some of you will need help with them. Okay, but I think probably the first thing you need to do is just sketch out these graphs, put on some values, and then, well, so actually sketch the graph, no, pause the video, sketch the graph, put some values on, and then we'll give you some questions and you can actually use your graphs to help you. Okay, so let's just fill in some values. We know 0, 360, so that must be 180. That's 90. That's 270, but you can also go into the negative. So that's going to be minus 180, minus 360, minus 270, hopefully yours is a bit neater than this, and minus 90. Okay, so now we've got our graph showing between minus 360 and 360. Now here we've got the cosine, sorry, half asleep, so that's 360, so half there is 180, that must be 90, that's 270. Right, so 360 plus 90, that must be 450. This is 540. And then this one is going to be another 90 onto that, so 630. I think. 560, yes. Okay, and then it goes down to minus 90. So basically each little thing is 90 degrees. Okay, but again, this one is going from minus 90 to 630. Okay, so that is your sine curve and your cosine curve, but I would suggest you probably only need to work on or remember the 0 to the 360. Okay, so sort of this bit of the graph. There will be occasions where your calculator may give you this value here when you actually wanted this value here. But we'll have a look at those probably tomorrow. Okay, so if you are happy with those, what you can do, you can go on and have a go at these questions. But it says state the two angles. We're always working between 0 and 360. So the first question's about sine. Question 5 is about cosine. So you've got your graphs drawn. See if you can get both values for each of those. Now, to help you, you might want to refer back to the answers. Okay, so all the answers are actually on there. And I'll put those back on in a minute, but you obviously better pause your video. But please make sure that you actually record your scores on Show My Homework. Give me some feedback so I know what we're working on Tuesday. So they're the answers for question 1 and 2. You may want to pause it there, or you may want to go on and check questions 5 and 6 and obviously pause it there. Okay, but any questions, put them in the chat. And as I say, we'll have a live lesson on Tuesday at 12:30. Okay, so hope to see you all then.